Good morning, everyone. Let's get started. Thanks for coming today, and welcome to SQL Bits. This is one of the first sessions of the event. And what a better way to get started than talking about SQL Server 2022. How many of you here have already started using SQL Server 22? So quite a few of you. That's great to hear. It's almost 1.5 years since the product has released, and it's being very popular, one of the most popular releases of SQL Server in terms of adoption is twice as fast as previous releases. There's a lot of hidden gems, right? Today we'll talk about hidden gems in SQL 22. Why hidden gems? Right? These are all some of the features which you do not see in any keynotes or flashy marketing materials, but still are very important for business applications to take advantage of to improve performance, availability, and various other scenarios. So my name is Ajay Jagannathan. I'm a principal group program manager at Microsoft. Our team is responsible for building SQL Server product that all of you know and love. And with me I have...
Hi everyone, I'm Dimitri. I'm a PM on the SQL team. I work on monitoring and extended events.
Yeah, thank you. So with that, in today's session, we'll cover a few hidden gems. There are a lot more than these, so we're happy to stay over, take questions at the booth if you have more questions. Today we'll be covering these 6 to 8 topics. Feel free to ask us questions at the end of each section so that we can address any immediate questions. If you have deeper questions, please come by to the booth since we have to pack a lot of content within the 50 minutes. The first topic I will start with is hands-free TempDB. How many of you love or hate TempDB? Right? Okay, so hands-free TempDB. Why hands-free? Right? So, I mean, TempDB has kept, I'm pretty sure, all of you awake at some point in your career, including us. Right? I mean, you get woken up for various reasons, on call, weekends, nights, daytime, doesn't matter, and it can be a disruption to the business. TempDB is a shared system database where it's basically like a dumping ground for various different activities that run in SQL Server. And over the years, we have seen different kinds of problems that surface there. It's like peeling the onion. Every time you fix one problem, you uncover a different problem. And the goal with, for us, at least in the product, is every time we learn of something new, a new bottleneck, how do we fix that so customers do not have to worry about it. So let me take you through a journey, right? Before SQL Server 2019, so TempDB was first in SQL Server 7.0 when we first started. If any of you have used that version, we introduced the term latches. Latches are internal system level data protection locks to protect access to metadata, and the system takes access on system tables depending on the activities you run. And in 7.0 we introduced the concept of latches to lock pages as they're being updated by system processes, right? Many of you may have heard of PFS GAM and SGAM. These are allocation pages which track space usage in every database, including TempDB. Page free space, global allocation map, and shared global allocation map. And these are used for any time you do insert, updates, or deletes for the system to go tell you which extents are free, where do I insert, where do I go and update the bitmap to keep track of the space usage, right? And every time that change needs to happen, the system process has to take latches there, which can cause bottlenecks, right? So one of the first recommendations we gave was this SQL Server uses a round-robin algorithm to allocate pages. So when we first, by default, when you start a database, it creates only one file. So the first recommendation we gave customers was go create multiple files, right? So many people started creating, we told start with 8 and go in increments of 4 till you hit a point where you don't get any benefit. So the first recommendation was to add multiple files. That way the workload is distributed. If concurrent inserts or updates are coming, they go to different files. But that was still not enough. Then we told customers use trace flags 1117 and 1118. I'm sure many of you are familiar with these. These were used to use equally grow files, because not just having multiple files is enough. They have to be equally sized. If they are not growing equally, then the one which has the most space is where most inserts will go. Again, you'll end up with the same bottleneck. And then 1118 is to switch from mixed extent to uniform extent, so that way multiple tables are not contenting on the same mixed extent. So we improved the experience in 2016 where we provided some of these best practices as part of SQL Server 2016 setup, where we will detect your system and create an appropriate number of files. We removed the need for trace flags because pretty much everybody was using the trace flag, so we made it default behavior and things like that. But the problems still remain, like the page free space concurrency issues. This is the system page which keeps track of which pages are free in the database so that we can insert. So that was the thing that was still there. And now some of the allocation contention were resolved. So we removed PFS concurrency in 2019. But now the problem moved from system page latch contention to system table contention. Right now, whenever you insert an object, let's say you create a new temp table, we have to make an entry in sysObjects, which is a system table. Or when you drop a temp table, you have to go and delete that. So that becomes a bottleneck. So you will see something like 2:1:, some large object number, right? If you do a DBCC page on that, it'll give you the system table name. That became a hot spot. So in 2019, we introduced memory optimized system tables with TempDB metadata optimization on, so which basically made these pages as part of memory, like it uses the same in-memory technology like Hackathon does, so you don't take latches anymore. That reduced that contention. But we still were left with SGAM and GAM contention. So now we are here in 2022. So I'm happy to share that we have completely removed the contention, and there is no more latch contention except for a very narrow scenario. So you can technically run with one data file and remove all the previous defaults, so you will get no more worries about TempDB. So, and that's another nugget, right? TempDB is a temporary database, so the data does not need to be persisted if a system crashes. We anyway create a brand new TempDB. So one of the things we also made is lazy log flush. So that way you don't have to keep checkpointing TempDB activity to flush the log, which will increase your load on your I/O for especially heavy TempDB loads. So we have also made this a more lazy algorithm, so it relieves some pressure on your I/O, right? So with that, let me quickly show you how this improvement works in 2022. So here you can see that this is only for demonstration purposes. Here you will see that I have one TempDB file and one temp log file. So we will go and experiment with this and see how this goes, right? Sorry, 1 second. Okay, so here I'm using the default settings, right? 64 MB growth, which is a new default, and you will see. Let's keep. Yeah, so 8 MB for data file, 200 MB for log file. We only have one file, so I'm going to go and run the system query. We'll use this query throughout the demo, and we'll do 3 tests, right? We'll turn off all the optimizations and fixes we have done in 2022 and see how the contention shows up. The first test will show you the PFS concurrency optimization only. We will turn off the metadata and the 2022 features, and we'll measure the performance of each of these features and how the contention has been removed, right? I've started perfmon here. I have 2 counters. Batch requests per second monitors my throughput, and the latch waits tracks how many latch contention I'm going, right? So let me go back to my stress tool. I'm going to turn off the optimization. So everything is the old behavior. Now I'm also going to restart SQL Server after turning it off. I'm using trace flags to turn it off because I'm running 2022. It's on by default. And I'm also removing the 2022 improvement and removing the GAM as GAM contention fix. Now let's go ahead and kick the perfmon on. I'm going to start ostress tool and run 25 concurrent threads. Now the green is the throughput, so you can see batch requests per second on the top, and then the contention is over the roof. Page latch waits, you're seeing around 200,000, right? When I go ahead and run this DM exec requests, you can see that there are a ton of procedures waiting on the latch. So this took about, if I go back to the thing, it took about 19 seconds. We'll make a note of this, right? And then if you look at the next one, we'll go and run the TempDB metadata optimization on. So this is basically now bringing us to end of 2019. So all the features that were added in 2019 for TempDB. So now let me go ahead and just disable the SGAM and GAM, which is 2022 feature. So right now you'll get the behavior by default what you will see in 2019. So let me go ahead and run the same test. You can see the throughput actually reduced with 2019. And the latch contention, let's go and run this query. It's still there. Now the latch contention, like I said, the GAM contention still remains. And now if I go back, the latch weights is still very high. It's not same as before 2019, but it's still very high. The problem is not solved. And you can see the query is running, in fact, longer than the first test, right? So now it just finished. Let me go ahead and stop perfmon here and note the time taken to finish this batch. It actually took 28 seconds, so 9 seconds longer. Now let's go to the last test, which is basically, I'm going to turn on all the features that we have enabled. So 2022 by default. So I'm going to remove all the trace flags I had used to disable it. It just means I have to restart the SQL Server and it'll start with all the default settings for 2022. And once the service starts, let's go back to perfmon and kick it again, and go back to the stress tool and run the same workload again with 25 threads, and go back to perfmon, and no more latches. Everything is gone, right? 0 latch weights. And you can see that the DMV queries returns the thing. So all your TempDB woes are gone with this, right? So you can see there is no more red chart. Batch request is almost twice the other two executions. And it also, the workload finished much faster than the previous 2 runs. So if we go look at the output of the query, you will see that it finished in 12 seconds. So there you have it. So we have taken the effort to remove all the common pain points. So if you're upgrading to 2022 and remove all your previous trace flags or settings, you will get by default the best behavior for TempDB and no more have to worry about 2 a.m. calls to fix latch issues. Yep. So that's the end of the TempDB demo. With this, I'll hand it off to Dimitri to talk about the next hidden gem.
All right, thanks, Ajay. There is a bit of an echo. You may want to mute your mic. All right, next let's talk about XML compression. This is a new feature in SQL 22. So what it is and why do we need this? XML has been present in the SQL Server database engine for a long time. Many customers have taken advantage of it, of the robust support that we have. And over the years, the amount of XML data stored in databases has grown substantially. In fact, we have customers who use predominantly XML data in their databases, and they have grown to multi-terabyte range. But one problem that we've had with this amount of data is that it's not compressed. It's stored in the LOB, large object allocation units, and the existing data compression that we have, raw and page compression, doesn't compress those. So in 22, we've added this new feature called XML compression, and the way you enable it is by either rebuilding an index with XML compression on, or by just creating it with that setting from the beginning. So for this feature to work, you have to use the XML data type. It's not enough to just store XML in varchar max, for example. You can still use raw and page compression, and that will be effective for other columns in the same table, same index, same partition. You can also estimate compression savings using the same estimated compression savings procedure that has been in the product all along. There is a new parameter called XML compression. You set it to 1, and then you can see. All right, so let's do a demo, and let's see how this actually looks. Okay. Okay. That is it. Okay. No, that's better. Thanks, Ajay. All right, so what I have here is I will create two tables. They are identical tables and very simple schema, just an int primary key and an XML column, right? So at this point, they are just identical, okay? So next, let me load some XML data into those tables. So I have an XML file on disk. I will load it using this xquery. Let me execute this. Now, there is actually another hidden gem right here. It's not new in SQL 22, but it's something I wanted to show. So what we have here is a single statement that inserts data into two tables. We have this inner insert, which inserts data into the uncompressed table. And then there is an output clause that returns the same data that we just inserted. And now there is a second outer insert that inserts data into the second table. So with one statement, we can insert data into tables. This is called composable DML. It has been in the product for a long time, but not widely known. So this is a very nice way to do things like that. So let's go ahead and get an estimate of our compression savings. So I've set XML compression to 1. Go ahead and execute this. Okay. So we can see that we have, without compression, about 100 KB, with compression, about half of that. So quite effective in this case. Let's go ahead and rebuild the index and set XML compression to on. This should complete fast. Okay. Now let's look at the metadata for these two tables. So we see that they have the same number of rows, same data, one without XML compression, about 100 megabytes, with XML compression, about half of that. So the estimate procedure was correct in this case. We get about 50% savings. Next, let's see how this performs in terms of query execution. So I will run two queries and capture statistics, time, and I/O. And this is, each query uses a simple range seek for 10,000 rows. So this returns some data. Now let's look. So for the uncompressed table, we have about 3,000 logical reads, and the CPU time is about 47 milliseconds. Now for compressed, logical reads is about half of that, so we've reduced our I/O by one half. The execution time, the CPU time, is about 187 milliseconds, so it's higher, but that's the cost of compression. Now, if you look at the elapsed time, it's actually not so different. So there isn't really much impact on query duration. So that's basically the XML compression. So would you want to enable it? It depends, as with any compression, but now you have this option in case you use a lot of XML data in your databases. Okay, next, let's talk about our next topic, asynchronous statistics update with low priority. So first, some background. We've supported automatic statistic update in the engine for a long time, and that's recommended, but there is a potential problem if you use that in LTV workloads that require very low and consistent query execution latency, because if a query detects that statistics are stale, it will auto-update statistics as part of execution. So if your query execution latency may be 10 to 20 milliseconds, if statistics update kicks in, that might all of a sudden spike into hundreds of milliseconds or more. So to deal with that, we've introduced an option to update statistics asynchronously. What this is, the query doesn't block anymore on statistics update. It continues executing with potentially stale statistics. But then on a background task, we actually update statistics so that future executions of the same or other queries can take advantage of new statistics. And that worked well for a long time, but we've noticed a fairly uncommon problem, which nevertheless was quite difficult to fix, because there isn't really a good way to fix it until SQL 22, where we introduced this option to update with low priority. So let me actually show the scenario of how it works. So let me. Yeah. All right, thanks. Okay, so here we have a statistics metadata object, and we have a number of queries that are holding a schema stability lock on the statistics. Why they would do that? Typically because they're all compiling concurrently. Right? They're creating execution plans, and we want our statistics not to change during this time because the query plan needs to be compiled. So what happens next? There is another query that comes in, and that query detects still statistics, and it initiates this asynchronous statistics update. That background task now is holding a schema modification lock on the same statistics metadata object, but it's blocked because schema modification lock is incompatible with schema stability lock. So at this point, there isn't a problem yet because it can just wait for a long time. Eventually, it will hopefully get a lock. But what happens next? Another query might come in, and that query also needs a schema stability lock to compile a query plan, and now it's blocked behind the asynchronous statistics update background process. And this is the start of a blocking chain. And at this point, you will find your queries blocked on a background process that is waiting to acquire a schema stability lock. So again, this is not common, but it does happen in workloads, especially those workloads where query compilations, query recompilations are very common and where they run at high concurrency. So what we can do now in SQL 22, we can enable this database code configuration, long name, async statistics update with wait at low priority. And what happens in that case, again, the same scenario, multiple queries holding schema stability locks on statistics metadata. There is a background thread waiting to acquire the lock, but now it's waiting on a low priority queue. What it means is that any new request to acquire a schema stability lock on the same statistics will not be blocked behind it. So at this point, a new query comes in, it gets a lock, and there is no blocking chain. Now, you may wonder, why is this not by default? So the reason is because there is a limited number of background threads, and if there are multiple asynchronous statistics update processes waiting for a long time, we could run out of background threads, that's one. And two, if the number of queries that are holding schema stability locks is high, we may never be able to get a lock at all, and then your statistics would remain stale. So that's why it's not on by default. That said, if you see the scenario where your queries are blocked behind asynchronous statistics update, we do recommend turning on this option. We see it actually making a large difference in customer workloads. All right, let's do a demo. Sorry. Duplicate. All right, so first, I'm going to start by creating a table with a single column. I'll create a statistics object on the table. I'll then insert 30,000 rows into this table. All right, then I'm going to start a long-running query that kind of simulates a query compilation. Because I'm using this DMDB stats properties DMV, it will hold a schema stability lock on the statistics object that I just created. So this will run for some time. Let's take a look at the locks on this table. So as expected, we just see a schema stability lock. So this is normal. Now, what happens if we execute a query that needs to update statistics on this table? So this executes. Statistics are updated asynchronously, so this is not blocking, right? But now if we look at the logs again, we see that there is this schema stability log that it was able to acquire, but then there is also a wait to convert that log to a schema modification log, and this is blocked now. So this background process cannot proceed because there is a long-running query holding the lock. So next, I can execute the same query again, and now this doesn't return because it's blocked behind this asynchronous statistics update. Okay, I'm going to stop this and this, and let's restart this. I'm going to recreate my table and statistics. I'm going to insert the same 30,000 rows. But this time, I'm going to enable this new database code configuration, asynchronous stats update wait at low priority. And let's start the same long-running query. Looking at the logs, same picture as before, schema stability log. Now let's execute the query that will auto-update statistics. It returns. Let's look at the logs again. And now the picture is different. So we have this low priority convert, right? So it's waiting for a schema metadata log, but on a low priority queue. And you can see that the wait type also mentions low priority. Okay, so if I go ahead and execute my query now, I can do it as many times as I want. It's not blocking. All right, so that's how this feature works in action. Let's move on.
Pause quickly. Are there any questions?
Please.
One online, which is XML compression. Is it useful for hot cache cases where we have all the log pages in memory?
Is XML compression useful for hot cache where all the LV data is in memory? Yes, it's useful because with compression on, you'll just have less data in memory. You'll have smaller memory utilization and less I/O as well to bring those pages in memory. Questions right here.
How strict is it in policing the XML data type? I mean, if I have a column that sometimes could be XML, sometimes could be JSON, what it does.
Oh, okay, so the question is how strict are we about XML data type? Very strict. So to use XML compression, you have to use XML data type. You cannot mix XML and JSON in the same column, then it will not be compressed.
One more question.
Yeah, please.
There is, for example, in the table, under the heavy load.
Okay.
There is any chance to refresh the statistics with this new thing?
So the question is, if the table is under heavy load, is there a way to refresh statistics? Yes. That feature may help, but it will only help if you have, if the heavy load involves a lot of query compilations and recompilations. If you don't have that, you can update statistics already because schema stability logs are compatible with most other logs. So you shouldn't have a problem updating statistics, even if the table is heavily utilized. Question online?
Yeah, question online. Is it possible to set low priority option directly in update statistics clause? For example, if I'm going to update stat during the working hours.
Okay, great question. So is it possible to set the low priority clause on the update stat statement? So no, not an option, but there is no downside in setting this option on the database level for all statistics update. And then if you need to turn it off afterwards, you can. All right. So our next topics is also related to statistics. There is a new feature called statistics auto drop. So what this is and why do we need this? Statistics are schema objects, and as any schema object, they can have dependencies on them. And if you need to change some other object in the database that depends on statistics, that can be potentially blocked if user-created statistics exist. So let's actually see how this works in a demo. Yep. All right, so I will create a table and a statistics object on this table. This is a multi-column statistics, and you may need to create this manually because the auto-create feature only creates statistics on single columns. So if I go ahead and want to alter a column on one of the columns that depend on the statistics, I get an error because there is a dependency, so we cannot do this alter. I can update statistics and set auto drop to on. And if I look at the metadata at this point, I see that I have the statistics object. It was user created, and the auto drop setting is now on. And now if I go ahead and do the alter, it succeeds. So very simple demo. So why would you need this? Sometimes a third-party application might create its own statistics, unexpectedly unknown to you, and then any kind of schema change you make would be blocked behind that. So that's something you can discover in advance. You can look at user-created statistics in your database, and if you find that some of them are not critical, you may want to set the auto-drop feature to on, so schema modifications are unblocked. There is a question?
Yeah, we have a question online, which is following on from the Evgeny's question, which was is it possible to set low priority option? The question is, are there any future plans to allow the low priority option, the update statistics statement?
So is there any future plans to allow low priority for an individual statistics update? No plans at the moment, but we would like to hear more about the scenario. So please send us feedback if you need it. We'd like to know why.
aka.ms/SQL feedback. So any feedback file there will come to us for us to engage.
All right, next, let's talk about some T-SQL improvements. So we've made quite a few of them in SQL 22, and those kind of enable things that you could do before, but not in a very convenient way. So we'll talk about is distinct from, which is a way to handle comparison with nulls in your T-SQL code. We'll talk about generate series, which is a way to avoid having to create a table of numbers in your databases. Date bucket is a function that lets you aggregate data by time ranges. Date trunk is a little bit similar. It lets you kind of remove a part of date time value and just leave, let's say, the rest of it. And then you have greatest and least, which are convenient functions to get the maximum and minimum value from a set of values, maybe from a set of columns, right? So again, let's do a demo. Okay. All right, so first let's talk about is not distinct from or is distinct from, very similar. So I have a table that I just created here. And the table is called toy, and you have two columns, name and color. And we can see that for some toys, we don't know what the color is, right? And we want to select all rows, all toys that are not silver. And if we kind of naively do this by comparing with the literal silver, we don't get all rows because some of them are null, right? So for some of them, the color is null. So what we could do then is rewrite the query in this fashion with a disjunction and or, and explicitly test for color null. And that gives us the right data as expected, but it's a little bit cumbersome. And we are used to writing queries this way with an or, but there must be a better way. So that's how we can do this with is distinct from. So we get the same data, but now the where clause is much simpler. And basically the way this clause works, it treats null as a value, right? So if you compare a null with a different value or with a different null, the result is never unknown. It's always either true or false, right? So it's just kind of a syntactic shortcut to simplify this type of queries. Next, let's talk about generate series. This is a new function. It does require the latest compatibility level 160. And what this does, it creates, it's a table valid function. It creates a table. You can define the starting point of a range, the ending point, and the increment. In this case, I'm using 0 to 365, basically the number of days in a year, and a 7-day increment. So you get this result set, and you can see that the weekly data is incremented in 7-day increments. Now, one thing I like about this is if you enable the execution plan, you can see that we get 53 rows here, right? Now let's look at the execution plan. So our estimate on the number of executions and rows per execution is exactly 53. Why is this important? With some previous ways to handle the similar kind of requirement with a table of numbers, you would not necessarily get the exact estimate on the number of rows returned. And if this query is referenced in some more complex, if this function is referenced in a much more complex query plan, you might get a poor query plan because of a wrong estimate. So this function always gives you the correct estimate on the number of rows that will be returned. Next, let's talk about date buckets. So this is useful when you want to aggregate data by a date range. So in this case, I'm using the date bucket function in the group by clause, and I'm aggregating data by 6 months intervals, right? So let's see how this looks. So we have basically a column that starts on January 1st, then July 1st, 6 months intervals, and you calculate some totals, right? So it's you could do this before with some date-time math, but this is just a convenient shortcut to avoid writing complex expressions. Date trunc, so let's just run this query because it will be easier to explain this way. So what you can see here is I'm truncating this first value down to a second, so seconds are 0. In this case, minutes are 0. Here we have hours and minutes that are zeros. So basically, we've truncated the daytime value, the current timestamp, to some lower granularity value, which may be, again, useful for various daytime arithmetic queries. Okay, last but not least, greatest and least. So here we are using the same result set that we got in the previous example to get the minimum and maximum daytime in a set. So the way to think about it, we have the min and max aggregation functions that work with a group by to find the minimum and maximum value in a set of rows. This can be used, least and greatest can be used to find the minimum and maximum in across columns, right? Not across a set of columns, but across a single row, multiple columns. All right. Question?
Yeah, going back to the XML. Are XML data still compressed in memory, not only in the buffer pool?
Correct. As with any compression, data is compressed in memory. It's not just a buffer pool. Okay.
Yeah, thanks, Dimitri, for a journey through some of the engine improvements. So now we are coming towards the second half of the session. So I'll talk about some more hidden gems. These are truly hidden. And the title of the slide says Purvi's list. Who's Purvi, right? And what's her list? So she's one of our performance engineers. Her only job in life is to make SQL Server engine go faster and faster. They run a lot of industry benchmarks like TPC, find bottlenecks in the low-level systems and try to address them, right? A lot of these are not easily tunable from a customer side of things, and because these are very low level in the system. And this is not something that you have to worry about either, but these surface as performance problems in your applications and generate support calls to Microsoft. So when we learn about this, we try and go and tweak the engine to make it run faster. And some of these are listed here. The first one is reduce buffer pool IO promotions. So what is that? So SQL Server has a concept called read ahead. You may have heard of this, and it's been there from SQL Server 7 over 2,000 days. So whenever we have to issue IO to bring some data pages into memory, we read in the form of extents. So an extent is 8 pages, so 64 kilobytes. So there are situations where you may not need to read the whole extent, because if you're reading only a few rows, which are all in one page, and yet that means you're reading extra pages which you may not need. So one of the algorithms she fixed is to make sure that we can optimize and predict when you want to read the whole extent versus a smaller set of pages. So this is something will reduce in the number of IOs generated, thereby reducing the compression, as well as optimize the usage of buffer pool itself, right? Because you're not bringing everything which you don't need. The second one is enhance core spin lock algorithms. So spin locks just like latches, which are used to protect data structures, spin locks are also internal data synchronization techniques to protect data structures. So we have made some improvements here to efficiently use spin locks so that it doesn't cross contention. And once you the main side effect that you will see when you have spin lock contention, just like latch contention, is it creates a blocking chain, and you have multiple threads spinning, waiting for that lock, and it'll waste unnecessary CPU cycles. So that's something you should look forward to. The second set of improvements on this slide is again something you may have seen regularly with database recovery, right? SQL Server transaction log is internally divided into blocks, which are called virtual log files. And the size and the number of these virtual log files usually impacts recovery time. Sometimes when your SQL Server crashes or fails over and restarts, you will see in the error log, your database is recovering, analyzing, undo, redo, etc. And this can take a long time if the number of these VLFs are inefficiently sized or very long. And it also can impact log truncation, because if a VLF is only partially used, we cannot truncate the log. So we made some improvements to correctly size the VLFs and create the right number of VLFs, which means you don't have to worry about this problem anymore. And the last one, how many of you have heard of instant file initialization for data files? Yeah, so this has been a problem, right? Anytime you have to auto grow, we have to zero the file. And then if auto grow occurs during the middle of a transaction, let's say you're inserting a lot of rows and you're out of space and you have auto grow turned on, the insert has to wait till the grow finishes, so you will basically be seeing a poor performance, right? So we introduced instant file initialization as a best practice recommendation. We also enabled it by default and set up in 2016, but it was only for data file, not for the log file. So if there are situations when the log file needs to grow, there was no IFI support till now. So which means if a log is growing, then the transaction has to wait till the log finishes growing. And the physical growth is always limited by how fast your IO subsystem is. So even a sub-milli transaction may have to wait for a few seconds in some cases. So one of the things she found was if your log file size growth is 64 MB or less increments, the Windows operating system presents the log already as zeroed out. So we don't have to do extra work to zero out the file. So this was a huge benefit, right? So if you right size a log file auto growth to 64 MB or less, then you don't have to worry about zeroing. We will automatically see a zeroed section every time you grow. So that way your auto grow is much faster. But I'm not recommending relying on auto grow. We always recommend customers to pre-size your log based on what you see as usage patterns, and use auto grow more as an emergency in case the log grows beyond that size. So that's the improvement. So let's quickly see how this works, right? So in this first demo, I'm going to create a database, right? With a 2 GB, you can see that it's a 2 GB. This is SQL Server 2019, so we can compare the difference. It's a 2 GB data file. And I've created a very small log file so that I can trigger auto grows. You can see 8 MB. And then I've set the file growth to 64 MB just to see how the difference is in the zeroing of the file. So next, I'm going to create a table, and then I'm going to insert a very large column so that it fills up the log quickly and it triggers auto grow. And insert a lot of rows so that it fills up the log. So let's go and run. And I also have 2 X events turned on to see the growth. There's a database file size change X event, which shows actual growth. And then the wait info external, which shows the Windows API we have to call, in this case, write file gather, to actually trigger the zeroing of the file, right? So you can see that the database file size change, that's in microseconds, so it's about 346 milliseconds. And then the zero of the file takes about 325 microseconds. And you can see the growths are always 64 MB chunks, right? And auto growth setting is turned on. And so you can see for every growth, we have to call the zero file, which is a preemptive OS write file gather. For very large transaction or a very busy environment, you can trigger tons of growth, which can be slowing down your queries, right? Now you can see the query itself took 17 seconds to run. And if you look at the wait stats, you can see the write file gather is the highest wait stats with about 8 seconds wasted in just zeroing out the file, right? So half the time of the whole transaction was spent in zeroing out the file. So what did we do to fix this, right? Like now if you look at even the number of VLFs, we had to create 51 VLFs across the log file, so that can also affect your recovery time, as I mentioned. So now let's go look at what we did in 2022, right? Exact same configuration. I create one data file and one log file, and same auto growth settings. Remember I mentioned that the growth setting has to be 64 MB or less for automatic zeroing, so you don't have to call the zero file. But I'll leave the size as 8 MB so we can show the growth behavior. I'm going to go run the same transaction workload here on this 2022 environment. You can see that it took only 7 seconds, right? So it's like 10 seconds faster than the other one. If we go look at the X events, you no longer see the zero, the wait info external OS write file gather. We only see the auto grow X events. So you basically shaved off all the time it took for the zeroing of the file. And the autogrow still takes time, which is why I said don't rely on autogrow as a default mechanism. It has to be more like an emergency failback if you run out of log space. And then let's go and look at the wait stats. And you can see that the write file gather is no longer in the list, which means it's not a problem anymore for your system. And if you look at next, if we look at the number of VLFs, we created half the number of VLFs, 26 VLFs. So it's more efficient from a log creations perspective. And that overall reduces one of the most common pain points we see with customers with transaction log space management. So hopefully that's another hidden gem for you to give you an idea of how we address this common problem. So as we are coming towards the end of the session, there are many more hidden gems that you can see here, like for all over the engine, whether it's related to query performance using query store hints instead of forcing plan guides. Now you can actually hint a query store query with the ID and simplifies your plan forcing. Dimitri talked about statistics with low priority. We also added shrink and create index with low priority so it doesn't block in some cases, so it puts in low priority routes. Accelerated database recovery, which was introduced in a previous version, but we made some algorithm improvements to run better, and many other things. And the last one is actually a big improvement, especially if you have to call support. Anytime you have to, support tells you to take a dump, it can intervene and pause your system. We have made an improvement to run your dumps in parallel threads. So dump generation is much faster so that you don't have to wait for a longer downtime. So that's overall journey of various hidden gems. These are not things that you will see normally in, like I said, in marketing slides or in flashy pages, but these are truly common pain points we are trying to address to help customers. A lot more resources to learn. These are all free for you to try. Most of this content, demos, everything that we shared today is available here. Please leverage this and reach out to us. We'll be at the booth all week. And more importantly, please do give feedback on this session, and if you like the topics here and would like to see more of this. And that's all, and hope you have a wonderful rest of the event. And thank you from us on this behalf. Yep.